SigmaNEST is an extremely powerful nesting software from SigmaTEK. SigmaNEST allows users to import many different file formats such as DXF, DWG, IGES, STEP, DSTV and SolidWorks, just to name a few. In this example, we'll import a DXF file. The import process is similar for all file types. The import dialog allows setting of material, thickness and quantity to nest. The green checkmark indicates that the geometry is correctly defined. Any errors in geometry can be repaired at this stage or using SigmaNEST's built-in CAD editor. Part parameters set various data fields appropriate to the part such as name, drawing number and revision. The material, thickness and quantity to nest can also be changed at this point. SigmaNEST comes with 18 customizable part data fields. These can be useful for secondary operations. The data added here is optional, only material, thickness and quantity to nest is required. SigmaNEST gives full control over lead-ins. In this example, we will set a lead-in and lead-out of 10mm by 45° to the part. This has been copied to all internal and external edges, although with options unticked, these can be set independently. Using the option Save to Lead-in Table will set these as default for the material thickness. The Cost tab gives a detailed analysis of the part costing, based on the material and operation costs, and time taken to cut the part. The material cost can be changed at this point, along with a markup for the part if required. Grain allows users to add optional engraving to the part, such as part name. The parts nesting parameters are also set here. Parts can be nested only at specific angles and orientations based on the material grain specifications. The part is now ready for nesting. The lead-ins have been correctly added. We will import 3 more DXF files maintaining the same material and thickness. The green checkmark appears, geometry is correct, and these parts can be imported. Lead-ins have been applied from the lead-in table. Starting a new nest operation in SigmaNEST is called New Task. All parts to be nested are moved to the right, and quantities can still be adjusted. SigmaNEST's inventory module holds a full list of all materials held in stock. For this example, we will add 10 sheets of 2m by 1m called Sheet Test 001. These sheets can be reserved for customers or available for general use. A number of further optional data fields are available for customers. Documents can also be added to be linked to the material. Any size stock material can be added, and with different sheet sizes available, the user can allow SigmaNEST to pick the best material to use or choose the specific order. Task parameters set the nesting parameters, again based on the material and thickness. Options include check lead-ins, common cuttings, choosing one of SigmaNEST's powerful nesting engines and clearances. The parts are ready to be nested on the sheet. SigmaNEST has loaded the 10 sheets and the parts to be nested are all on the right, all with a quantity of 0 of 15. AutoNest will automatically nest the parts based on the task parameter settings. All the parts have been successfully nested on 2 sheets. The parts on the right have all gone green. It's important to note that SigmaNEST allows full automatic nesting, manual nesting, or a combination of both as shown here. Extra components can be added if part overrun is applied in the task parameters. Once the parts are nested, moving to nesting NC adds machine code to the nest. As with nesting NC gives manual or automatic control over the code. Using Auto NC applies settings indicating the cutting order and if part avoidance is to be used. For large skeletons, SigmaNEST can use Profile Destruct to cut the skeleton. In this example, the only option added is a straight crop line with a remnant to be created based on area size. Further options include common cutting and tabbing to keep the parts attached to the sheet. Setting as default will again remember these settings for the material and thickness. SigmaNEST has a 2D simulation with cutting indicated in red, engraving in white and rapid moves in dashed white. The simulation shows each part processed in turn, etching and cutting. This can be changed in the Auto Nest settings to machine all engravings on the sheet followed by all cutting. With the parts nested and the NC code applied, the part programs can be post-processed. 2 programs are created, one from each sheet. The programs are generated with the cutting times for each. SigmaNEST has several built-in reports, fully customizable. Here we are looking at detailed analysis and layout detail. Detail analysis includes a full breakdown of all the parts, processes and times associated to each sheet. Layout detail is a more basic overview and is particularly suited to machine operators to see what will be cut on each sheet. Finally, SigmaNEST will update the stock accordingly. We can see that of the 10 sheets initially added, only 8 are available for nesting, 2 are tied to the programs created. Program Update is used when the sheets have been cut on the machine. Updating will remove the programs from the list and update the sheet list.